Okay, so it comes back down, down, and then it kind of bends like that, right? So like this. So you have that particular curve going in that direction. All right. Now, how about to the left of that point? It looks like it is going down like this. See, like that. And it goes back up like that. No, it's not right over here. So can you see what I'm doing? Okay, let me use the thicker line to do that. So you see, it looks like this. Oops. Okay. Oh, right. Okay, so it goes like this. Arrow, arrow, and the 0.10 is right here. So this is the graph of B. Okay. Yes.
So what's the like the margin of error in these graphs? Because I feel like you could go on like on the left side, you could have gone a little bit more higher, right? So what's like
Yeah. That's fine. And you can go a little bit higher. Okay, this point right here is not accurate, right? You see, it's not parallel to this one and that one. So you might have to go back and adjust that. See, and it could be up here or down here, but but it shouldn't be that much. So the margin of error would be like your graph should be somewhere in like for this one, it should be somewhere in between these two, right?
yeah.
So like you see the gap is between these two, You got the point?
Yeah, yeah.
Okay, all right.
So there is no perfect answer, right? It's more so,
No. But the shapes of your graphs should look similar.
okay. Makes
Okay. Of course, there's no way say, okay, you make sure you better get the exact line, the graph like I have here, right? Impossible because your graph could be a little bit lower, could be a little bit higher over here. Okay.
Yep.
All right. So I hope I answered your question.
Yeah, you.
Okay. Now I hope you know how to sketch a solution curve when I give you a direction field. Okay. Now the next question is, how do you construct a direction field like this? And believe it or not, when I was in school, we had to sketch a direction field by hand. During my time, there was no graphing calculator at the time. Okay. So we had to do a lot of things by hand. So we had to do a lot of work. Okay. You guys are lucky nowadays because you have technology, okay, and things are easier. But there is a trade-off, right? Like my kids and my former students always complain. They said they wish they were born years before, like during my time. Okay, they said they wish they were born during my time, so that now, so that they could be able to buy a house because now, like even if you graduate and you get a good job, you might not be able to buy a house, right? Okay, for a while because it's so expensive now. Okay, but and then the older people said they wish they were born during this time, so they have all the technology and stuff, so things are much easier. And I can tell you, nowadays, learning stuff is much easier than us back then. It was a lot harder for us to learn. No internet, nothing, right? No solution manual. So if we got homework to do, the only way we can get help is from the professor, right? Nowadays, I know students, they just go online, go to slater.com or Khan Academy or whatever other sources that they can just get the solutions, right? I know some students, they can even get the instructor solution manual. They can buy it online. Okay. So now it's easy to, they have easy access to those things. But that could help you or that could hurt you, right? Because if you abuse that too much, it's going to hurt you. Okay. So but you know, I know what has been going on, but make sure you guys learn responsibly. Okay. So because this will help you in the long run. Okay. Also, all right. But of course, you know, like we just say we wish, right? But whatever happened back then and whatever we had, we dealt with that, right? We didn't have things like you guys have right now, you know, like with a phone, smartphone, you do things. We were happy to have a bicycle to ride, right? Okay, so we had nothing. Okay, all we could enjoy our life was like on a weekend go to the parks, right? And play basketball because there's only one ball and a lot of us had fun with it, right? Nowadays you guys just had fun with your phone, right? And so it's just different. Okay, so with that being said, I want to share this with you. Okay, because I always share things with my students, like things in real life, because I have friends who are doctors, who are pharmacists, who are dentists, who are lawyers, who are engineers. Okay, and at this level, see, I don't share this stuff with the lower level math because in a way, even though they are adults, but they are still not mature enough. Okay, so I don't want to scare them too much in terms of education, right? But at this level, okay, I want to share this with you because my friends who are chief engineers and software engineers, uh, I have one who's working for Google right now, and I have one, and she is working for Microsoft, and you know she get paid over $300,000 a year. Okay, that's how much she made, and she only has a bachelor degree in electrical engineering, right? But she has a lot of patterns that she came up with, and so and then her job, she was working for Rhombus, and they laid off the entire team because of COVID-19. So you know they just couldn't sell off the products, the stuff that they did. So they laid off the entire team. But her team was so good that Microsoft hired the entire team, right? So they hired the entire team, and this is what these fans told me when they interview young engineers nowadays. No more bachelor degrees. Okay, bachelor degrees is nothing. All right, so keep that in mind. Okay, so don't you think that when you have a bachelor degree then you think you're done with college. I advise you not to. And that's what I keep telling my younger son, right? Because he's going to UCLA, and he said, okay, if I graduate, I'm going to make six-figure salary. And I told him, son, okay, you can make six-figure salary, okay, now, but over the years, your job won't last because you know the economy fluctuates, right? So when the economy is good, they keep you. But if the economy crashes, you're going to be laid off, right? And if you are laid off and during laid off time, I don't know, it could be 2 years, okay, 1 year, 2 years, 3 years. And during that time, it's going to be extremely difficult and very challenging for you to compete with other engineers who got laid off too. Because if you have a bachelor degree and those have master degrees and PhDs, they're not going to hire you unless you are really, really, really good. I'm talking about like 1 percentile or 5 percentile, right? Okay. So I told my son, okay, he's going to graduate soon, probably 1 more year. He took a lot of classes when he was in high school, right? So and then he's going to graduate early. But I told him, okay, don't even think about going to work because you're too young. He's like 21 years old, right? You go to work, you don't have enough experience to deal with politics and stuff at work because he never worked. If you guys have been working to make ends meet and to pay your tuition fee, then you have that survival skills. My younger son doesn't. Okay, they've been, baby too much, right? Okay, so they don't know how life is out there. Okay, I wish if I could go back, I would make them work. Okay, but it's too late, right? It's too late. So, you know, they know that, right? They know that. So, you know, it's better for you to have experience. You earn your money, you know what to do with your money and so on. It's better. But I told him, be prepared, okay? Because you know you're gonna graduate soon. So study prepare for the GRE test for graduate school. Okay, I said, I would like you to go to graduate school. And I said, I will pay everything for you. All right. If you go to school, I pay everything for you. That's what I have been doing. We have been doing for the older son and younger son, because at least you get a master's degree. Okay. So that is better it's easier for you to compete. And with a bachelor degree from UCLA, you can get a very good job right away. I'm telling you, if you graduate from like UCLA, UC Irvine, UC San Diego, UC Berkeley with a bachelor degree, for the last 2-3 years, my friends who have kids graduate from there in engineering, they get like $80,000 jobs, right? They got offer right away. Okay. But the problem is, yes, you get $80,000 for your salary now, but you know, I'm sensing that the economy is going to crash pretty soon. Okay. Because there's that cycle, right? So, you know, it's just a matter of being lucky when you graduate at the time when the economy is up there. My wife, she graduated at the time when the economy crashed, right? Her friends and she could not find an engineering job. So they had to look for technicians positions. And when they look for technician positions, they had to hide their bachelor degree. Because if they knew that you had a bachelor degree in engineering, they wouldn't hire you, because hey, these guys are just work here for a couple months, and when they and then they try to find a full-time job and they're gonna quit, so we're not gonna hire them, right? So they just hit the engineering degree to work as a technician. Okay, that's how bad it was back then. Okay, but if you're lucky, you graduate at the time when the economy is good, you get a good job. But that is luck. That is good for you, but in a way, it's not good for you in the long run. So nowadays, like I told you, my friend says when they hire engineers, a lot of them get PhDs. Okay, and master degrees is the lowest. And she also shared with me that they have PhDs, but they don't have the experience. So when they work on a project together, they are trying to sit here proving things, right? Why things work? Because they get so used to proving theorems. And she is the chief engineer. She said, hey, listen, I've been doing this for almost 30 years. You listen to me. I said, if you do this way, it's going to work. Okay. But those young engineers, they don't want to listen. Say, no, how can it be? You know, I have to prove it to make sure that it works before I do it. And she said, we have only 1 month. Okay, make it work. Okay, we have to make it work. And then when we're done with the project, then you can try to figure out why it worked the way it worked. And then you come back and you teach me. But now I teach you how to make it work first. Okay. Okay. So that it's very hard for you to break that habit of proving things, because you're coming from graduate school, you prove a lot, you prove theorems. Okay. But when you actually do the things, it's hands-on experience. It's very important. Okay. So with that said, I share that with you now. So think of going to graduate school also if you can. Okay. But I told my son this. I said, if you get hired with good pay, like very good pay, right? Okay. Over 100K. Ask them one question. Do you pay tuition fee for your employees to go back to school while working? Okay, if yes, we do, take the job. Okay, go to work. After a few months, then you can be a part-time student, a graduate school student. Take 2 classes per semester. They pay for you, right? You go to work, you earn money, and then they also pay you to go to school. Okay, what can be better than that, right? So that's what I told my son. But if you get paid below 100K a year, I would like you to continue school. Okay, because if you don't continue with school, after a year or so, you don't feel like you want to go back because it's, oh my God, I have forgotten everything. I forgot all the calculus stuff that I learned. I forgot all the differential stuff that I learned. I forgot all the engineering courses that I learned. So it's harder for you to go back. You can, a lot of people go back. It's hard, but they wanted to get a master's degree, so they have no choice. They just go back and then they review the stuff, right? Okay, if you have a will, then there's a way. Okay, all right. So with that being said, okay, make sure, don't think about, after I get my master's degree, I'm gonna quit school. No more school. Okay, don't have that thinking. Okay, don't do that, because you never know. You might go back, continue school and get your PhD. But if you major in computer science or engineering, when you go to graduate school, a lot, I mean like over 50%, okay, of all the courses you're gonna learn involve mathematics. And those are the mathematics that I learned when I was in undergraduate school. So all those majors, engineering, computer science, computer engineering, all those, okay, graduate school, the courses involve a lot of mathematics. So please don't say you hate mathematics and you don't like mathematics, okay? Because you're gonna see them a lot. All right. I talk too much about real life, okay? But I just want to share this with you so you know what is ahead of you, okay?
Hey, Professor, I think there's a student who got his internet connection dropped and he's trying to get back in the class.
Okay, I don't see that. Because if they come back to class, then on my end it should show me. Oh, okay.
Yeah, I think
Thank you. Miguel, how did you see that? Because it doesn't.
I'm not sure. It's just I think I just saw him disappear from the class, and he's in one of my other classes.
Where did you see it? You see it on your Zoom screen?
Yeah, just like from the students, like up top from their camera, I saw his feed drop, and we talk in other classes, so
he's also my friend too. He just messaged me that he got disconnected.
Oh, okay. Yeah. Okay. Sometimes it doesn't show me. Okay. So but yeah, thank you for telling me. So if there is a classmate whose internet is weak and they get dropped and they try to come back in and I don't see it, please let me know. Okay. Okay, so now I'm going to show you how to sketch a direction field by using the method we call isoclines. Okay, so that is the next example. So so this is how we're going to do it. All right, isocline. Okay, so the way it works is this. Okay, so I give you a differential equation. So what you're going to do is you just draw your xy axis. All right. And then you can scale it any way you like. Okay, you can scale it any way you like. So let's say you say 1, 2, 3, 4 like that. Okay. So each square is 1. All right, and I always put arrows at the ends of of a line. Okay, so the method of isoclines works like this. Okay, so you have your differential equation. Remember, this is the first order, right? First order differential equation. So this is y prime is like the slope, right? Y prime is the slope of the tangent line to the solution curves at a point. So that is actually your slope. So that is m. Okay. Excuse me. So now you want to find out different tangent lines at different places. So the method of isocline says, okay, let's do this. Let's find out where all of the tangent lines with slope 1 are. Okay, and we get all of those. And then you go to slope when the slope is -1. So if you ask me why 1, Well, it doesn't have to be 1. You can, if you want, you can get 1/2. You can get like 0.3 if you want to. I just like to work with whole numbers. That's all. Okay. So the question is, okay, what happens? Where does it have all the slopes at 1? Okay. So so let's do this. So this one means y prime is 1, right? Okay, so what does it mean? That means when x is equal to 1, all the tangent lines passing through this line will have slope 1. Now, what does a tangent line with slope 1 look like? Okay, so based on your scale right here, for the x scale and the y scale, let's say draw, for example, if you have a line like this, that is with slope 1, right? Because the rise is 2 and the run is 2. Does it make sense? So where is x equals 1? I'm gonna draw this over here and I'm gonna erase it later. I draw this as a guide for me to get the slope. Okay, so the line x equals 1 is right here. I'm gonna erase this one later. Okay, so one advantage of me using this to teach is I can just erase it very easily, right? In your case, I guess maybe you can make the little lines in ink, right? And then you can draw this one in pencil, and then later after you get all of those, then you just erase that line, okay? But right now I know that this is my line x equals 1. So any tangent line passing through here has to have slope 1. That means any little line on here, they must be parallel to this one because this is slope 1 right here, right? So you kind of, it can guide you. You see right here, you see like this point, you can see it has to pass through here and here. So that is the 1. So I'm gonna draw that, okay? So I'm gonna draw that. All right, okay, like that. So I see I'm just aiming for like this to pass through this corner and this corner, okay? It does not, so I'm gonna do that. So make sure that it passes through that. You get the point?
Yeah, that makes sense.
Okay. So you see that? Okay. You might ask, why do we just draw these little lines right at the corners here? Why not here or there? Yeah, you can draw it any way you like. Okay. But if you make it too much, they look too busy and it doesn't look good, right? So just do some. So that should be enough. So now I have those passing through the line x equals 1. Does it make sense? Now you go to the next one. What about the slope being -1? So when the slope is -1, then I know that I replace y prime with -1. Then I know that all the tangent lines passing through this line right here will go down because the slope is negative, but the steepness has to be 1 going down. So you know that it looks like this. Right? So this is when like the slope is -1. So make sure, like, so where's the line? Where's the line? X equals -1. Well, which is right here, right? You can just draw it right here in pencil, and then you can erase it later. Oops. Okay, so now I'm gonna draw lines going down with slope -1, roughly like that. Okay. Now, like I said, during my time in college, we had no complaint, right? Sometimes we have to spend a lot of time doing things. We never complain. Okay. If we were able to do a problem then we were happy. Okay. So no complaining at all. Okay. It's just different nowadays, right? I remember my professor used to say, "Oh, I'm just they just look at the exercises in, say, section 2.1, and he would say, well, these problems look good. Okay, so why don't you try to do as many problems as you can?" That's what he said. Okay, as I hate that, when it says do as many problems as you can, then I said, please tell me which problems to do. Okay, because there are too many problems in there, and we wouldn't know which problems are good and which problems are not good. And someone said, "Oh, all of them look good to me. Just do them." I hate that. All right. So now, when the slope is 2, so y prime is 2. So now, let's see what the tangent lines look like when they pass through the line x equals 2. So x equals 2 is right here. Right here, x equals 2. So I suggest you to use graph papers when you do this, right? Because with graph papers, it's easier. So, and then the slope is equal to 2. So if you have a point right here, the rise is 2 and the run is 1. So the tangent line is that steep right there. Okay. So that's what it looks like. So make sure it is that steep, right? Wow. So it's going to be, so basically, if you have a point here, the next point has to be right here, right? So you have to draw a line. So it's easy. You use a ruler. And your ruler pass it through this point and this point. Okay, put your ruler passing through this point and this point, so you know that the slope is 2, and you draw a little piece right there. Okay, that is much more accurate than what I'm doing here. I'm just eyeballing. Okay, when I do this, then it might not be as accurate. No, that's too steep. Okay, let me use my ruler, because when I put my protractor on here, it is very slippery, and it make things move. Okay, so I have this. Okay, there you go. Okay. All right. So can I stop? You understand how to do it now? It's just a matter of time, right? It's very time consuming. But the important thing is you understanding how to do it. Okay. So you do it for some of them. You do it for what, like when the slope is 0 also, and see what happens, right? When the slope is 0, then x is 0. So x is 0 is the y-axis. So on the y-axis, the slope is 0. So you have like horizontal tangent line. You see? So they are horizontal, because right here, okay. So x equals 0 is the y-axis, and then you have horizontal tangent line. So you have that. All right. And when you do a few more, then you will see that you see a bunch of parabolas. So you know the solution curves are parabolas, and the vertex is going to be on the y-axis. So it's like this. See, like that. Okay. If you do enough, then you can see them. All right. So that is what it means by the method of isoclines. Okay. So isoclines means you naming the value of your slope, and then you find out what you have. Sometimes you may end up with like a linear equation, like 1 equals x plus y. So if you have 1 equals x plus y, right? Let's say, for example, you do have that, then you know that y is equal to 1 minus x. So you have to draw in pencil this line right here, and then on this line, the tangent lines passing through this line will have slope 1. That's what it means. Okay, we happen to have just vertical lines, but in general you could have any line. So just draw that line in pencil and then get a bunch of marks on there. All right.
So Professor?
Yes.
So there's no difference between the ticks you made on x equals 2 and x equals -1 or 1. Is it just the steepness of it or what?
The steepness. So you see right here, if you compare these two, if you extend these, then you can see that the slope here is going to be 1. So because this is going to pass through this point, right?
Yeah.
So you know the slope is 1, but this one right here is going to pass through this point. So the slope is 2. So these are just showing you the steepness of the slope at that particular place or point. Does it make sense?
Yeah.
Okay. So that's what they are. You see the steepness, okay? How steep it is and the direction it is going. All right. Yeah, I know this section is going to take more time, okay? All right, but now let's go to the next part. Now you learn another form of differential equations, and we call it autonomous first order differential equations, okay? So what is an autonomous first order differential equations? Well, you know, first order means the highest derivative is the first derivative, okay? Now, what does it mean by autonomous? So we go back to chapter 1. You see the normal form of a first order differential equation is when you have the derivative by itself, and then on the right side, you have a function containing both the independent and the dependent variables. Okay? So again, that is the independent, right, variable. And that is dependent variable. Okay? So that's what the right-hand side is. Now, I named this differential equation star. Okay, so that's how I name. See, in the book, they call it like 1, 2, right? Okay, so I like to call it star. Okay, so now, if the right-hand side of that equation does not contain the independent variable x, that is, if the right-hand side is just a function of the dependent variable only, okay, then we call that an autonomous differential equation, okay? So that's what it is. All right, so we call that an autonomous. So then we call the differential equation an autonomous first order differential equation. Okay, so that's what it means. All right. Any question on that? Very easy to understand, right? Now, here are some examples. So when you look at the derivative, identify the independent and the dependent variable. So in this case, which one is the dependent variable? This one. Which one is the dependent variable and which one is the independent variable?
The dependent is P.
Good. The dependent is P, right? So in order for this differential equation to be an autonomous differential equation, then the right-hand side should not contain which variable?
T.
T, right? Because T is the independent variable. It shouldn't be here, right? So it's not there. It's only the dependent variable. So we call this one an autonomous first order differential equation, okay? Same thing here. Now you guys should know what that is, right? That's the Newton's law of cooling and heating, okay? So you see on the right side, we only have the dependent variable t. This is a constant. There's no lowercase t here. So that is an autonomous differential equation. And this one right here. So you know, if you did your homework and studied, and you know that this is a mixture problem, right? Like that is the mixture problem, okay? And it doesn't contain t here. So that is an autonomous differential equation. And so is this one, because the dependent variable here is x, okay? Is x. So that's why it is, it's just my my notation for going back and make this one go up here just to revise my notes. That's all. Okay, so all of these are autonomous differential equations. Okay, now let's talk about a critical point. This is different from critical points that you learn in calculus 1. Okay, so what is a critical point in this case? So here's a critical point of the autonomous differential equation. So this is the autonomous differential equation. So a critical point of this one is a real number c, right? Is a real number c, such that this autonomous equation is equal to 0. Okay, that's what it means. So if you have an autonomous differential equation and you want to find a critical point, you just set it equal to 0 and solve. When you set it equal to 0 and solve, basically you're finding out when y is equal to 0. That's all. Okay. Okay. So right here it says d. So this is your autonomous differential equation, and it is equal to y. Implies y is equal to c, right? Whatever c is, that makes this guy 0. And you know y could be a function of f. Okay, well we use f right here, so I guess we shouldn't use because f and then y is c. That means when you plug it in here, you get 0. So this value, we call it a critical. I abbreviate number. Okay, it's called critical number. So note, I use a lot of notes, right? To find a critical point, or I should say a critical point, not number. Critical point. To find a critical point, we set f of y equals 0 and solve for y. So basically you set this equal to 0 and solve for y. Okay, so a critical point is also called an equilibrium point or a stationary point. Okay, so they mean the same thing. So make sure you know that, right? So equilibrium point, stationary point. Okay, they all mean the same thing. Okay, so example. We have example 1, 2, 3, 4. So it should be example 5. So let's call it 5 here. Okay. So I give you this autonomous differential equation. So you want to find the critical point. So basically what you do is, you know that, so you set the derivative equals 0. So implies that is 0, right? So you can just factor 1 minus y. Okay, so you know that from here, you know that y squared is 0 or 1 minus y is 0. Yeah, everybody should be able to tell what y is from here, but I like to show more steps, and that's fine. So you know that y is equal to 0, okay, or y is equal to 1. So there are two critical points here, okay? So you say, therefore, the critical point of of the differential equation, not of y, okay, but of the differential equation are 0 and 1, okay? Or you can say are y equals 0 and 1, all right? And then you can just box, okay? A phase portrait. What is a phase portrait? Okay, so this is the next topic that you need to know from this section. And this is also from one of the student learning outcomes. All right, that means, so you know how important it is for you to know this, right? So if you read the student learning outcomes, it says somewhere about phase portrait. So it says somewhere in here. I'm pretty sure. Okay, right here. See, student learning outcomes number 2, right? So construct the solution curves from the phase portrait of a first order autonomous equation. Okay. All right. So what is it? Okay. So if you have a, let's consider the autonomous differential equation here. Okay. Consider this. All right. And then you want to find the critical points. So, to understand what a phase portrait is better for me to do an example and show you what it is, okay? So basically you find the critical points. So basically you write, all right, so the derivative, and make sure you pay attention to the independent variable because sometimes they use t instead of x. So if you get so used to working with x down here, then you just keep writing x all the time, but it might be t, so you have to write the correct variable. Okay, so then you take the right hand side and you set it equal to 0. Okay, or let's do this. Let's do this extra step first. So you know that the right hand side, which is this, right? So you know that y1 minus y equals 0. So y is equal to 0 or 1, right? So you know that the critical points are 0 and 1, okay? So of the differential equation are y equals 0 and 1, all right? So now, locate the critical points on the y-axis. So you have just the y-axis, all right? So it doesn't matter where you want y equals 0 is on the y-axis because normally you can put at 0 at the middle or down. It doesn't matter, okay? But I'm going to say it's right here. All right, so this is when y is equal to 0, okay? And let's say this is when y is equal to 1. Okay, remember there's no x here, right? There's no x here, so x could be any real number here. Okay, so now you locate the critical points. Now you want to find out the signs of the derivative. Okay, so you want to find out the signs of the derivative, just like similar to what you did in calculus 1. Okay, so these two critical points divide the y-axis into 3 intervals. This interval right here, this interval right here, and that interval right there, right? So we want to know what happens to y in each interval, okay? For example, when y is bigger than 1, what happens to the derivative, and then from the derivative it will tell you what happens to the curve, okay? So when y is bigger than 1, dy dx, dy dx is this times that, right? So let me write over here. So dy dx, I'm gonna highlight these two, and you find out the signs, okay? So when y is bigger than 1, that you plug it in here, that means that is positive. Do you agree? When y is bigger than 1, then you know that it is a positive number times. If y is bigger than 1, what do you get right here?
Negative.
Negative. All right, so that is what you get for the derivative. So when you have a positive times a negative, you get negative. Okay, so when you get a negative number, so if the derivative of y is negative, implies dy dx is less than 0. If it is less than 0, what does it tell you about the function y from calculus 1?
Decreasing.
It is decreasing. Very good. Okay. So the y function in this interval right here is so when y is bigger than 1, is the y value is getting bigger or getting smaller? It is decreasing. So you know that, yeah, and so you know that when you have the function y, you know that for this interval right here, your y is decreasing. So you just use the symbol like this to indicate that your y is getting smaller in that interval. Okay? And you do the same thing for the interval in the middle. So if you pick a y in here, let's say anything in here, 0.5, and you plug in here, 0.5 is positive, you plug 0.5 in here, that's also positive. So you know that dy dx is positive times positive. So that means dy dx is greater than 0. So what does it tell you about y?
Increasing.
Increasing.
Increasing. Okay. So this is a good review for you, right? For calculus 1. Okay. So that is increasing. That means if in this interval right here, your y is getting bigger, so your y is going in this direction, it is increasing. Okay. Now, how about here? You pick a number here, let's say -1, and you plug it in here, you get negative. You plug it in here, you get positive. Okay, so negative, positive implies dy dx is negative, so that's less than 0. So if the derivative is negative, what does it tell you about y?
Decreasing.
Decreasing. Okay, so that's what you have. Okay. All right. So after you get all of that done, right? Okay, this is what you have. Okay, I'm gonna use I don't know what color to use. Okay, I'm gonna use this color right here. Okay, that one right there, everything there. We call it a phase portrait of the differential equation. So basically, a phase portrait is something that tells you about the dependent variable y. Okay. All right. All right, so any question about that? Okay. So with that, now let's go to the next one. So now we're going to study attractors, repellers, stable, unstable, and semi-stable. So what does it mean? So we are talking about a critical point being called an attractor being called a repeller, or being called stable or unstable or semi-stable, okay? So let's read the definition, okay? The critical point y equals 1 is, okay, so here's the critical point 1. You see y approaches 1 from both sides, right? From the top and from the bottom. See, y is getting close to 1 from down here and getting closer to 1 from up here. So from both sides, the y values are getting closer and closer to 1. So we say this critical point is stable, okay? Because as x approaches infinity, y approaches from above and also from below, okay? Because y approaches 1 from above and below 1, all right? So I don't know, I guess stable, oops. Okay, so that's what it means by being stable. Now, the critical point y equals 0. We say it is unstable because the y values are traveling away from that point instead of toward that point. You see the difference between the two? Y is getting closer to 1 from both sides, but 0, y is getting away from 0, y is getting away from 0 from both sides. So we say it is unstable.
Wait, sorry. In the previous one, it says hence 1 is called an.
Where?
In number 1 at the very end, hence 1 is called an.
Oh, what we call? Thank you. We call it an attractor. So if it is stable, then we call it an attractor. If it is unstable, okay, so because as x approaches 1, y travels away from 0, okay? So we call 0 a repeller. Okay, so now I would like to take you to figure 2.1.9 on page 42, so you can so I can show you more about being semi-stable, okay? Because we don't have that here. So basically, being semi-stable or semi-unstable is like the value, the y values pass through the point instead of getting closer from both ends, but it could pass through here and it continues to pass through. So we call it unstable, okay? Semi-stable or semi-unstable, same thing. So with that said, then we are done, okay? But let me take you back to the book where that is. It's 2. What did they say? 2.1.9. 2.1.9. Okay, so make sure you read more on this one in the book, okay? So you see, like if you have the points, then you know the graph, right? So make sure you read that. So, but let's go to 2.1.9. See, like here you have, so from the phase portrait, then you kind of figure out what the graph looks like, okay? Where's 2 point? Okay, right here. All right, so let's say, so in this case right here, you see, so let's say this is a critical point, right? Okay, critical point. and y is getting closer to c from below, and y is getting closer to c from above. That means if you pick any y value and use it as an initial value, right? You remember you have like a differential equation with an initial condition like this, right? So if your initial y value is right here, then you know that the curve is going to get close to this point, okay? Okay, so the y value, all the y values will get close to this value c, okay? So it will tell you more, okay? And right here, c is right here, and the y values are traveling away from c. So this is stable, this is unstable. But let's look at this one right here. So here's the critical point. So you see right here, the y value is getting close to c from below, and then c is getting closer to here, but it passes through c and it continues to go up, right? So basically it is passing through c and it continues to increase up here. So we say this critical point is a semi-stable, or you can also call it a semi-unstable, okay? Same thing either way. Same thing here, you see? So you see the y value is getting closer to c. However, it keeps passing through c and it keeps going away. See? So it goes either all the way down or all the way up, passing through the c. Then we say it is a semi-stable. Okay? That's all it that's what it means. All right. Okay. I wanted to lecture section 2.2 also, but that's okay. I'm going to stop right here. So we can spend, so that's it, right? So let's talk about quiz number 1. Okay, so this is just a the student's contract, so make sure you submit it, but I want to share with you on how to take quizzes. So I'm gonna reshare. Okay, so I'm gonna reshare. So I'm gonna go over here. I'm going to give you some time to do this, but let me go to Canvas now, okay? So Canvas. Differential equations. Okay. So here's the assign. I have the first quiz. Okay, the first quiz is right here. So make sure the file is named as your last name, comma, first name, and then parentheses quiz 1B, okay? And then you say contract or just contract in there, all right? So it would say clearly. So let me show you what it says, and then you can do that, okay? So on the quiz, it would say something like this. So this is just, okay. So when you click on the quiz, I don't know why it's so slow. Come on. All right, so you're gonna have like the directions, like for the real quiz later on. Okay, I haven't put the Zoom link in here, huh? Okay, but you click it on here, and then so make sure you close everything, because starting from quiz number 2 on, and also the midterms, you can only have the Canvas tab and your Zoom tab. All right, nothing else, because if you have other things, you may be kicked out of the test of the quiz, and you get a 0 for it, because then Proctor will think that you are cheating by having an extra tab with other websites that you can get visit to get help. Okay, so that's why it does that. All right, and after that, then you click on Zoom link again to let Proctorio know that you are trying to open Zoom link, because you are not allowed to open any link unless it is within the quiz. So when I put a link in here, that means you can open it because Proctorio knows that I allow you to do so, all right? But don't just go up here and then open another tab, then you're gonna be kicked out, okay? So this is, and then, you know, when you read all the directions and then down here, you're gonna see the quiz question. It's gonna tell you what to do and how to name your quiz, right? So make sure you name the way that I asked you to name here. And please pay attention to the spaces, all right? Like I told you, well, why I do this, right? Because I want to train my students to read directions carefully and treat directions with respect. Because if you don't, you're going to get into bad habits, and later on when you try to apply for a job and they give you a set of directions you don't follow, and you try to submit your resume and application, they're going to put your application aside. They're not going to consider, okay? When you go to an interview, you're supposed to dress a certain way and do certain things, right? So all of those things, and I have over the years, I see even like instructors, right? When they apply for a full-time job, and I'm on the hiring committee, and I see that they just have no idea on how to present themselves, okay? And I say, well, maybe you were not trained when you were in school. Your professors, your teachers didn't teach you how to do certain things, okay? And I hate to see that happen to you guys, all right? So when I do this, some students, they don't like it and say, oh, he's too picky, this and that. But remember, who cares how you name it, right? I do this because I want to see if you know how to follow directions, because this is your life and this is your future here later on, okay? So make sure you read slowly and understand what it is saying. Don't read it too fast. See, I say it clear right here. I said, do not upload the file here. No, use my email address to email the file to me. And some students in the past still click on here, and then they just upload the file here and submit quiz. Don't do that. I said do not, right? It says, please scan your signed contract. All right, save it as a PDF. Name it this way. It has to be a PDF, and then use Canvas inbox. That means right here, right? And submit it. Okay, so I told my morning classes that if, or I'm telling you now, if you have Canvas app on your phone, it's going to be faster for you, right? Because you have your contract already. Use your phone to scan it. Using an app to scan it as a PDF and name it like this, okay? And then on your phone, you also have Canvas app. Just click on Canvas and go to inbox and email the file to me. I don't know, for some reason, a couple of students this morning, when they sent me their contract, they said they told me they name it the way I asked them already. But for some reason, when they sent it to me, the name was not the way it was supposed to be. So make sure when you send it to me, try and send it to you also, and see what name you get on there. All right. And before you send it to me, open your PDF and see if it looks good, because a couple of students this morning sent it to me and I couldn't even read. It was too blurry. Okay. So make sure you check all of those things. All right. And very important is anytime you take a quiz or a test, always click submit quiz to tell Proctorio that you did take the quiz and you submitted it, okay? Even though I asked you to submit that file in here, but you still need to click this one right here, okay? All right, so with that being said, let me, so why did you prepare? Okay, so prepare scanning your content. I hope you already did, but if you haven't, make sure you do that now and you have it ready to submit, okay? So, but let me add that link.
Are we using Proctorio for this?
This is a practice quiz, or actually it's an actual quiz, but it's good practice for you. So you know, when you take an actual quiz, which is quiz number 2 on Wednesday, you know exactly what to do.
Wait, this Wednesday?
Are you asking me a question?
Yeah, is it this Wednesday, then quiz 2?
Yeah, I will say I will write it in the tentative schedule. Okay, but let me hold on. Let me do this real quick.
Is there a particular subject line the email should have?
You can write quiz 1B. Okay.
Okay.
Okay, so make sure you submit the quiz to me. I'm gonna let me adjust the time. I put the time a little bit too close. So it has to be, so make sure you submit the quiz and check everything before you leave. So treat this one like a test, okay? Because if you leave Zoom meeting before submitting the test, you're gonna get a zero fault, okay? It's like when you take an actual face-to-face class and then you leave class and then you come back and turn in the test later on, okay? That will not be allowed, all right? So make sure you submit before you leave. So let me do this real quick. Okay. So are you logged in your Canvas?
Yeah, I am, but I don't see anything.
You don't see anything yet. Okay.
Ditto, I don't
Now
see
you
anything.
do. So please do that.
Excuse me, I can't find the quiz.
Okay, now you should see it.
Yeah, I see it now.
Okay, you see it now, right?
Yep.
Yeah. Okay. If you need any help, speak up, okay? Because this is a practice quiz for you, so you learn how to do it. Otherwise, starting from quiz 2 on, okay, you need to know what to do.
So should we hold on? So we send the email right after we click submit quiz.
You can do it before or after. It doesn't matter. Okay.
Oh
But
wait,
if
I
not,
already sent the email. Should I just send it again?
When did you send it to me?
So no, I thought we were supposed to send the email. So I sent the email, but then I see then it popped up. It didn't pop up before on the syllabus, and now it's asking me for an access code.
If it asks you for an access code, that means you have violated Proctorio.
Okay.
Yeah, sometimes just make sure you're out of you're not in incognito mode.
Okay. I do not require an access code. So when you take an actual test or a quiz, and this happens to you, and you cannot take the quiz and you run out of time, I cannot do anything about it, and you're gonna get a 0 if you cannot take the quiz. Okay. So you have to follow the directions that I indicate on there. And I don't know why some of you didn't follow my instructions. Why did you email me the contract before? I didn't even give you the quiz before. I'm giving you the quiz now, and this is when you're supposed to email me. See, you email me too many times, I'm gonna get confused. Right? So please follow the instructions.
So when we finish the quiz and then send it to you, do we leave the class?
Yes. Okay. So quiz number 2 is going to be on Wednesday. Okay. I will send an announcement to tell you exactly what is going to be on there, so you can study for it. All right. So I will do it right after class today, this evening, so you know.
This one,
Professor.
Okay. So make sure you check the file to see everything is good, and then submit it, and then you can leave. All right. You have a good evening.
Is anybody else not able to access the quiz? It's still saying remotely proctored. I closed all the other tabs and I have nothing else open.
same from me.
What do you have on? Did you go through the steps? Yeah, the only thing I have on is Zoom and the one tab for Canvas. Everything else.
Okay, and did you click on the Zoom link inside the quiz?
Yes, I
No,
did.
it won't. It doesn't show a Zoom link in the quiz. All it shows is remotely proctored.
No. If you click, okay.
So are we supposed to log out of this Zoom meeting and then rejoin with the link on the quiz?
I don't think you have to do that. Did the rest have to do that?
Professor,
Yes.
So even if we submit it, it's just showing missing after we click submit quiz.
Missing because in the question itself, you're supposed to choose. Let me show you. But don't worry about that. Okay, if you submitted a quiz, then you're fine. Okay, okay. Do you see my screen?
Yes.
I don't think it's going to allow me to take the quiz now or to show you now because the quiz has started already. I don't think it's going to let me open. Let me try.
I
Okay.
think we need to download the portfolio.
Well, yes, of course. I told you guys already. Before school even started. If you don't have it ready, you're going to get a 0 on this quiz. Okay. Right here. You do this and you click on that. And you close everything, right? So you close everything. Okay, you close this, you only have Canvas. And you click on this one, it's going to take you to Zoom again. Don't close your Zoom, okay? You're still in class. Let's click on this to let Portfolio know that. All right, and then you take the quiz.
Professor, do you want the subject to be anything specific?
No, you can write quiz 1B if you want.
Quiz
okay.
1B. Okay.
Yeah.
Thank you.
Okay, so remember, you should always read the announcement and go to the homepage. I spend a lot of time doing this for you guys, and I sent out the information a few days or a few days before school started, and you guys didn't even bother reading this and all the stuff here, and even on the syllabus. I told you clearly that you need to have Google Chrome and install Portfolio, and you didn't do that. And that's why you will get into some difficulty now because you don't have Portfolio, you don't use Google Chrome to do that, okay?
Professors, I've done both of those things. I was able to get into the quiz. And I apologize, but from my understanding, we're supposed to send you the quiz or the contract via private message on Canvas before we hit submit quiz, or we're just supposed to log on to the quiz, hit submit quiz, and then private message you.
Okay.
There's just been a lot of perspectives shared. So
let me explain one more time, okay? You log into Canvas, you see this?
Yep.
You go to assignment.
Yes, did that.
Okay. You open the quiz.
Yep.
Okay, let me try and see if it allows me to preview it, okay? It doesn't. It doesn't because I already started the quiz, okay? So it doesn't allow me to do so. So let me do this. So let's say you open the quiz, right? And then on your end, you're gonna see these directions, and you see the question down here for the quiz, right?
Yes.
All right, and then it gives you the direction. So now, if you were to take quiz number 2, you're gonna scan your papers, right? You scan your paper and save it as a PDF, name it correctly.
I have.
Okay. And are you gonna use the same computer to submit the file, or you're gonna use your phone?
Same computer. I have it already. I have it ready.
Okay. So if you use the same computer, then when you click on the box, it's gonna kick you out of the quiz. So once you know exactly what you're gonna do, right? You already get the name of the file correctly. Just click submit quiz to get out, and then you go to inbox and send me that file. Okay.
Okay, that's what
Everybody
I thought.
got that? Okay. All right.
Did you get my quiz by chance?
I cannot check right now. Okay, so check your sent folder because I'm still talking to the class, so I cannot go to the inbox and check all the emails. Okay.
Okay.
If the quiz says late, it's still okay, right?
For today, for this time it's okay. But
okay, thank you.
But starting quiz number 2 on, when they say make sure, if they say, all right, you have 2 minutes to submit the quiz, that means you have to submit it by 8 o'clock. So you know exactly by what time you have to submit the quiz. If it's after that, I might not accept it, or I might take points off. Okay. All right, and you guys, Again, I don't want to keep reminding you, but starting on Wednesday, if I see your webcam off, I will remove you from the class, okay? Okay, I hate to keep repeating, but I think it is very disrespectful when you can see me and you can see your classmates, but we don't see you, all right? So please.
Professor, I have managed
Yes.
to get access. So just to check, we're supposed to send it. So where it says question 1, we attach it there, and then we also email it to you.
You use inbox.
Okay.
Okay, inside Canvas to submit. Do not use my email address and email it to me. Okay, it's gonna be lost. All right. Okay. If you have any questions, I'm here to answer for you. And this is the only one time I can help you on this. But on Wednesday, when you take quiz number 2, I don't want anybody to disrupt the class. Okay. So make sure you know how to do it now.
It's not letting me send you an email.
What is not letting you?
So Canvas right now, it just has the quiz open. It's not letting me access.
You're supposed to. Okay, you have the file ready. Okay,
Yeah,
I explained it to Miguel a while ago, and I hope you listen. Okay, C1 and the piece. I have to remove you. Okay, you guys. And I don't want to say too many times. Okay. John, are you here? John is not here. Okay. Once you have the file ready, and when you are ready to submit, are you listening? Okay. Below the screen on the right-hand side, do you see submit quiz, the button?
Yeah.
Just click on that.
Okay.
Okay. Now you can click inbox and send me the file.
Okay.
Okay. Any other questions?
Oh, Professor?
Yes.
I was trying to get into the quiz, but it says it's locked now.
How come you didn't get into the quiz when I published it?
I forgot that I didn't have Proctorio pre-installed, so I had to take like a few minutes to install it.
Okay, so you did not do everything that I asked you to do, right? And so you waited until.
Well, I was preparing my email beforehand, so
I'm sorry.
I was preparing my email beforehand, so I didn't know
What
I had to go
email?
in for Canvas, the Canvas email. I was preparing my message and putting the file on there.
Okay.
But I had to delete my message, go to the assignment. But then I realized I didn't have Proctorio pre-installed for some reason, so I had to go install that.
Okay, but I asked you to do that a week and a half ago.
Yeah, I thought I had it pre-installed, but
yeah,
it wasn't showing up for me for some reason.
Okay, so you need to email me the file and explain that to me in there, and we'll see what I can do for you. Okay.
Okay, because I have the message. I wasn't able to, start the quiz, but I can send the message.
Okay. All right. Next.
Yeah, Professor, I have a quick question. This is outside the quiz though, but say for example, like Wednesday coming up, right? And we have a quiz. Say if I'm doing my homework on my computer, if my proctor is on, it's not gonna let me go into like anything else, huh? Like it won't let me open up anything like Google Docs or anything.
When you actually do a quiz or a test,
yeah,
it will not let you do any of that except in Canvas itself and in within the quiz itself.
Okay, so you can't do your homework on computer and submit it, right? Because I won't know which number.
No, you mean you cannot do your quiz or test, right? Not homework because it's a quiz or a test.
I know, but your quizzes aren't. Didn't you say your quizzes are homework problems? You said, right?
No. It could be a homework problem. It could not be. It may be just like a quiz or a test that you were to take in a face-to-face class. So it means I'm going to give you a quiz. I will pose some questions. You read the questions and you do it on your paper.
Oh.
Yeah, and then you scan your papers and turn it in.
Oh, I thought it seemed like a homework problem. That's
Okay,
why.
for homework, yes. So you know, for home. So if I collect your homework to grade as a quiz,
Yeah.
then I will not enable Proctorio. Okay.
Okay, that makes sense.
So you can still get your homework file on your computer to submit to me.
Yeah. Okay,
Does it make sense?
Yeah.
Okay. So yes, just use your laptop or computer and do your homework on there and save it as a PDF file. Okay.
Yeah. Makes sense.
All right. Next question.
I have a question regarding to the quiz on Wednesday. So we need to submit this on in PDF file on Wednesdays, right? But how can we upload it into the file on the canvas? Because if we scan by phone, right, and we have to upload it into our computer to put it on canvas,
Okay.
right?
All right. Then one way to do that is by downloading Canvas app on your phone. Okay.
Okay.
So when you are on your laptop or your PC to take the quiz, all right?
Yes.
So this Wednesday is gonna be you need a piece of paper to do your quiz. Okay. So you do your quiz and you scan it, right?
Yes.
And then when you are ready to submit it to me, then on your PC, just like today, inside the quiz below, you see the button. It says submit quiz, right?
Okay.
Then just hit submit quiz. Just click on that to submit the quiz.
Okay.
And then now you use your phone, you log in your Canvas app, and then
Okay.
you inbox me the file that you just scanned. You got that?
Yeah, I get that. Thank you.
Okay. Wow. So a lot of you guys don't know how to do this. I thought you guys did, but I'm glad I used this contract as a practice quiz, so students can ask me questions. All right, next question. All right, so you guys have submitted the contract already? Okay, that's
I
it.
have a question for the inbox. Is it okay if because then when I do on the phone, it says like you have in order to send the email, you have to do a message. So can I just write the message as like last name, first name, quiz 1B contract?
That's the name of the file.
I don't know. Yeah, but then like you can't. For some reason when I send
it requires you to say something.
Yeah. Can I say?
Say here's my quiz.
Oh, okay. I just said the name of it again.
Okay, yeah, just say something. Just okay. Here's my quiz 1A or 1B, right?
Yeah.
And on Wednesday, just say attached is my quiz 2B. So say something. The more important thing is your file. Okay, okay. Because when I open your email, I just download the file.
Okay. Just for the message, I just put the name of the file.
Yeah, that's fine.
Is it okay with the subject? Because for the subject, I also put the name of the file too.
Yeah, or just say quiz. Quiz
Okay.
1B or quiz 2B.
Okay.
All right.
Mhm.
Okay. Okay, next question.
For what we just did, 2.1.
Okay.
For the last one, number 2, the critical point y equals 0 is unstable. I didn't get the last part that we got after that because as x approaches infinity,
it's called a repeller. Okay, let me. 2.1 lecture notes. This one?
Yeah. Oh, it just travels away from 0. Okay.
Repeller.
Hey, Professor, can you hear me?
Yes, I can hear you.
Oh, I cannot submit because it says it's locked, the assignment.
Because it's too late. Okay.
This was locked.
Okay, so like you were supposed to hit the submit quiz.
Yeah, but
by
I
the
had
end
a
of
lot
the
of
class.
I had a lot of problems to.
Okay, but don't worry. Okay, don't worry. Okay, you just need to send me the file.
Yeah, I already sent it in the inbox.
You already sent it, but
Yeah.
okay, don't worry about this time on that quiz. Okay, But starting on Wednesday, when you take all the quizzes, make sure you hit the submit quiz and also send me the file before the time is over. Because I will give you an advance notice. I said, okay, you have to submit the quiz by a certain time. Make sure you do it by that time. Okay.
Okay. So yeah, it was a lot of problems. This is the first time I do that.
Okay.
Yeah.
All right. There's always first time. That's why I use this contract as a practice quiz. So you know what to expect. Okay, from here on. All right.
Yeah, I mean the proctorial, so I never used it before.
Oh yeah, that's why a lot of students had a problem when they like the high school students, they graduated and then they went to San Jose State this last semester, and then they had to it's like Zoom classes, and professors don't even proctor, right? They set proctorial, and then students, they go in and they will warn ahead of time that they're not supposed to turn their head like that. Okay, I look down, I look up, they get kicked out, they get a 0.
Oh yeah,
Because proctor says you're cheating. See, I don't want to do that because this is a math class. You guys need to look down to right? I don't give multiple choice question. Even with multiple choice question, you still have to do some work. So that's why I don't enable that feature. Okay. So when you take a quiz or a test, I still watch what you're doing with proctorial. What proctorial is helping me is it prevents students from like cheating, like open by opening an extra link or tab. Okay, then proctorial is going to know that, and it's going to record your screen. Whatever you do, it records everything, and then I can watch. I can go back and watch what you were doing during the test time or the quiz time, and what links or what websites you visited, and so on. Okay.
Also, because I have my screen, it's big. Sometimes I have to see.
Okay, that's okay. As long as you don't open another tab, then you're okay.
Oh, okay.
Okay. All right.
Okay. All right.
Danny, it seems like you have another question.
Yeah, for this Wednesday, is it just going to be chapter 1? Or are we including 2.1?
Remember, I just lectured section 2.1 today, so I'm not going to test you on that next time on Wednesday. Okay. I always allow you guys one class meeting to ask me for help before I quiz you or test you. So wait for my announcement in Canvas. I will say clearly what sections to study. Okay.
Okay. Thank you.
All right. Sure.
I have one more question.
Okay.
So you know how every like the next week you might collect the homework.
Yes, I might collect it anytime.
So does that mean we should have it like pre-scanned, ready to send?
When I collect the quiz, you can pre-scan if you like. Okay. But when I collect the quiz, I do give students about 5 minutes to scan and submit. Okay. But if you pre-scan everything, what if I only ask for one problem? Okay, but one problem, it wouldn't take that long, right?
But then you're getting everything then, regardless.
Okay, because sometimes I could just collect one problem to grade. Sometimes I collect everything, right? But when I collect everything, I might just glance through and see if you did the work and I gave you credit for it. Or I just picked one problem from everything to grade for half credit, and the rest I just glance through and give you half credit, okay? Okay, I do that besides having actual courses in class to take, okay? So always do your homework.
Okay.
All right.
And then I pre-scanned 1.1 and 1.2 because I didn't know if you were like gonna like do like kind of like the quiz where like you have to.
I don't know either, okay? But I might change my mind and collect it Wednesday or next week, right? Okay. Okay.
Yeah.
All right. Good. You have a good evening.
Professor?
Yes.
So earlier I was able to send the full message. So once we have the message with the file sent, we can leave the class, right?
Okay. So once you send me the file.
Yeah, I sent it. I put it in the message. I attached it.
Okay, inbox, right?
Yeah, in the Canvas inbox.
Yes, then you're good. Yeah.
Okay, thank you.
Oh, sure.
Bye.
Danny, more questions?
I was just waiting for when he left.
Oh, okay. All right. Bye-bye. Okay. How about you, Kendall? You have more questions?
No, I think I don't have any more questions.
Okay, great. Okay, so I see you guys on Wednesday.
Yeah, take care. Bye.
Have a good night.
Bye.